to the ECS, the electric car system.
Hi, I'm Tim Godself, and I've come up with a feasible alternative to the petrol car and the current transport road system here in the UK and the world, called the ECS. Why? To tackle the increasing problems that the current system is having. The ECS has been designed to tackle the following: the lowering oil reserves to produce petrol for our cars, hence the massive increase on oil petrol prices for consumers. According to reports, some suggest oil reserves will not meet demands by 2020. Road safety. Road-related accidents are one of the highest causes of serious injury in the UK. Traffic offences. Traffic congestion. The environmental issues. Petrol cars contribute a great deal to global warming. Parking problems. And road noise. To tackle these issues while keeping our existing road network to limit the cost of this is to design a new vehicle for British roads. Meet the ECS car. It's a self-driven vehicle and half the width of the average motorcar. The reason for this will become clear as I take you on a demonstration of exactly how the ECS can tackle all of these road transport problems. It's important for the government to take on an idea like this one and give the necessary investment. In fact, they will need to avoid a human disaster. It is a system that can be phased in over a number of years across the UK, starting with chosen cities perhaps by 2060. Before I show you how the ECS will work with the existing network and other transports, let me highlight the main points and aims of the idea. It's a self-driven vehicle, so no need for driving licence or taking a test. People as young as 10 can have their own designated vehicle. Each vehicle will have enough room for one adult and 2 or more under 10-year-olds. Eliminate drink driving and speeding offences. Increase road safety by at least 90%. Greater energy efficiency over petrol cars. Vehicle made fit enough to enable the vehicles to park on the side of all B and A roads. Most freight to be carried via our existing railway network, with some of these electric cars being designed for the pickup of freight from the nearest train station with no passengers needed to homes and businesses. For the ECS to be in full operation across the UK by 2060. To relieve congestion in towns and city centres, for example London, as it's half the width of the average petrol car. This will allow double-lane traffic as parking will not be allowed in these areas except the outer lane for short drop-offs. The vehicle will then go and park itself at existing car parks for these town and city centres. Also, to help relieve congestion, these vehicles can drive much nearer to the car in front. Reduced running noise. Electric cars are much quieter than petrol vehicles. This will also include lower volume of emergency sirens. The system may encourage more cyclists and pedestrians and help reduce obesity. Right, let me show you exactly how the ECS will work. Now, I've already said that the ECS car will be self-driven. So how can a car drive itself around our existing road network? Well, research and development is being carried out on vehicles that can do just this.
But if we can just hop inside here. Once you're inside, you then press a button to choose your destination and off you would go. Now these vehicles are driven by a computer. If you see here, there's no driver at all. The car is being controlled by a computer and a laser sensor that's reading the road ahead.
Now, to help move this technology on and help guide our ECS vehicle, I came up with the idea of perhaps injecting a microchip into each cat's eyes that already exist on our British roads to help steer the vehicle and also tell the vehicle its exact location. It can give other important information like the maximum speed limit for that road or even for that part of the road where it bends. If we could find a cheap and easy way of putting microchips into cat's eyes, this can be picked up by a vehicle using a scanner, just like we do with animals. Now, of course, we already have a way of telling you, or in this case the car, where and how to get somewhere using satellite navigation systems. These systems can be used to tell the vehicle where it is to travel to by the passenger before departing. However, this could also take the place of putting microchips in cat's eyes and saving the cost, as satellite navigation technology is advanced enough possibly to be able to steer a car through the roads safely. Take the cybercar shown earlier. This vehicle has onboard laser and radar technology to detect obstacles in its way, i.e. someone running out in the road or other vehicles, much more quickly than humans could manage to respond. However, using these technologies also helps reduce congestion as described here with the cybercar.
Instead of having 2 seconds between vehicles, we can have 0.5 seconds between vehicles. So you can multiply by 4 the number of vehicles going through a highway. And with the maximum safety.
Now, with all of these 3 different guiding technologies on board the vehicle, there's no need for traffic lights or road signs. Each vehicle will be able to communicate with each other, telling each other where it is going and doing via perhaps a Wi-Fi radio communication link. So there would be no collisions at crossroads, for instance. There can be computers installed in junctions that can also direct vehicles and tell them when they can go, a bit like how a traffic light system would work, in prioritising according to perhaps how long a vehicle has to wait or slow down for its turn. The vehicle will have wheels that do a 90-degree turn so that it can park on the side of the road quickly and easily. An electricity supply will be given along every stretch of road, with each spacing or parking spot having a charging point and enough space between each parked vehicle for a pedestrian crossing. This will include a button to press on the charging point to stop traffic at any time to safely cross the road. A radio signal will tell the vehicles to stop when the button is pressed. Each time a vehicle parked at one of these charging points, the charger will connect to the vehicle automatically to charge the vehicle's battery. It's always a good idea to keep the car's onboard battery topped up. The electricity supply will be paid for like any other public service through council tax, for instance. Every road with the ECS will be able to turn down into cul-de-sacs for parking at your house or business. However, minor roads will not allow the ECS. Therefore, if your destination, home or business finishes at the end of a minor road, the vehicle will park to the nearest available spot, including car parks if necessary, on A or B road. Therefore, passengers will have the choice to walk, cycle to their home or business, or even use a golf buggy type of vehicle, a bit like the Fiat Pogo here. This vehicle has a maximum speed of 20 to 25 miles an hour, and will be useful if you're carrying some objects. This vehicle can be safely used by anyone over the age of 16. In towns and city centres, no parking will be allowed on the side of the road. Instead, the out of the 2 lanes will drop off passengers and then park itself to the nearest car park. Passengers will then mobile their vehicle to come and collect them from a drop-off point. The ECS vehicles will automatically park on the nearest free spot in both directions to allow passing of modified emergency and essential freight petrol vehicles through the centre of the road. Special licenses will be given to a small amount of drivers of these modified petrol vehicles that the ECS cannot cater for. The ECS will be able to have transporter type vehicles to deal with the majority of small to medium sized freight, coming mostly from our local train stations. The petrol vehicles will be modified with laser and radar technology for maximum safety, as well as the radio communication with the ECS vehicles so they know in advance to park on the side of the road to get out the way. Now, each petrol vehicle will need to enter their destination on the satellite navigation system just like the ECS before departure, so each vehicle knows exactly where they're going. Now, in the rare event 2 petrol cars going in opposite directions are going to meet on the same road, advanced warning will be sent to each vehicle, telling the other to pull over on the side of the road to let the other one through. Of course, emergency vehicles will always be given the right of way. Now, along most of the B and A roads where this might occur, spaces or laybys will be created for these petrol vehicles, trucks and lorries, for instance, to pull over to one side. These spaces will mean no parking for the ECS. The laybys or spaces can be put along these roads apart from maybe small villages, etc., where every space will be needed for ECS parking, for instance. But each petrol vehicle will be given plenty of warning of any oncoming petrol vehicles so that it can pull over in plenty of time before entering a small village, for instance. Children from 10 years old can either be monitored by parents from a home computer or still be travelling with them just in another vehicle. Talkback systems can be installed to allow for communication between vehicles of family members travelling with you.